Delighted and honored to speak before you this morning, and in a context where I propose to take you through general comments first on the development of solar around the globe, as well as the cost of solar energy to be compared with other sources. Then we will go through the inevitable topic of regulatory frameworks and subsidies to this industry, before going through the financing issues and the risk-sharing profile, and then some case study. There's a trend of the solar installation to grow. Each size of plant are growing, and most of the development is in the photovoltaic sector. There's only little capacity in thermosolar. Thermosolar has been developed mostly in Spain, and you have a few other plants around the world, including Project Shams in Abu Dhabi. But thermosolar is much more complex, it's less flexible, and this is why it has been less developed. What are the market trends for the next decade? We believe that Europe will continue to lead this market, although we also expect other regions like the US or China, where lots of equipment suppliers are coming from, to develop further. The scale and the performance of the photovoltaic sector will improve, will continue to improve. There's always a research to improve the cost. You will see it's very expensive. So there's always new material that are being introduced, new technology to improve the yield of this sector. The industry is still very fragmented. You have almost all the supply chain with lots of players, and there's only the silicon part of the supply chain which is very concentrated. So otherwise very fragmented, and we expect the market to consolidate going forward. What are the merits and the disadvantage of solar energy? On the benefit side, of course, the obvious one is the unlimited and free fuel. It's of course, I mean, a key advantage. The next one is the fact that it is very easy to install. Very easy to install, very flexible. You can have very small installation, and this is obviously one of the driving factors. Of course, it's environmental friendly, no emission, no sulfur emission, no CO2 emission, no noise, and this is very valuable in our world. On the disadvantage side, basically you have two things. First, the cost. You will see the cost of solar energy is really high, especially the capital cost. And the next disadvantage is that, like wind, it's not a reactive energy. So the more you develop solar capacity, the more you need other form of generation, like peakers, to be able to match the power demand curve. And this is a very important factor to remember. What are the key drivers of the development of solar energy around the globe? Unfortunately, the driver is not the merit that we have just seen on the previous slide. The driver has been the political will of governments to incentivize by subsidies this form of energy, because it is so costly that without subsidies, investors cannot get their return from the sale of power. So the main drivers so far have been subsidies. And this is why, if you look at the world map of the installation, you will see that Germany counts half of the installed capacity around the globe, because Germany has been very generous in the subsidies that has been granted to the sector. The problem in Europe is that with more and more constraint on budget, there's some policies that are challenged, and in 2010, lots of European countries have cut the subsidies to the sector. So let's go to the cost of solar energy. In this slide, which I picked up from the International Energy Agency to have quite an homogeneous set of data, you can see the all-in cost of the various forms of generation. It includes the investment cost as well as operating cost, and with regard to the number of megawatt per hour produced, of course, it takes the expected load for each type of generation. So I guess that, like me, you may question some of the figures. I mean, we know all the debate on, the cost of nuclear. You can see also on gas that with, I would say something like $80 per megawatt per hour, we may challenge a bit this figure. On my side, I believe it's lower than this. But still, I mean, it's very illustrative, and you can see on the right-hand side of the slide the cost of renewables. Wind is already expensive, but onshore wind, is still not that far from other conventional sources of energy. But solar, as you can see, is well above $300 per megawatt per hour. It's nearly, 400 in some countries, but let's have in mind an order of magnitude of 350. It's very, very high. And this is almost 100% made of the capital cost. In fact, in solar energy, you have 95% of the all-in cost, which is made of the investment cost, and it's almost, made of the panels, the inverters, and the installation cost are really only 25% of the total investment cost of this energy. So you can see the variable cost, the fuel, we know it's free, the sun, but the investment cost is really making the bulk of this $350 per megawatt per hour. The good news, though, is that over time, the cost has continuously been decreasing. If you look at the chart, I'm sorry because it's very small, but you can see the blue line is the crystalline silicon, and the yellow line is the thin film technology. So I would say the two most popular technology used in the photovoltaic sector. And basically, on average, you have had a 20% reduction in the cost as the installed capacity doubled. So it's a very significant reduction. As I was telling you, there's always new material that are introduced. There's also the volume growth of the sector, which has fed research and development and innovation, and also producers have developed larger manufacturing plants that really provide economies of scale and optimization in the process. What we have seen in the photovoltaic sector, however, is not the same in thermosolar. Thermosolar, again, you need a real steam turbine. There are complex elements in those plants, and we have not seen a reduction in the investment cost like we've seen in the photovoltaic sector. So, what are the implications of this? Lots of subsidies have therefore been necessary to develop the sector. But the problem was that the reduction in the investment cost brought by all those innovation and optimization have not been followed by an adjustment of those subsidies. This is particularly true in Europe, and therefore the subsidies have continued to feed the industry, and in the end they have fed an uncontrolled bubble. And because of the crisis, the economic crisis and the budget constraint that has been increasing, indeed, the whole system has been challenged. And in 2010, as I was telling you, lots of countries have really revisited their policy and put an end to those, I would say, unfair return for investors. And this is particularly difficult for industry players because it brings instability, and as we said before, as Jonathan mentioned, instability of the regulatory framework or the political will behind a sector is very disturbing. And so over the last few months, investment in the sector have really halved because of this uncertainty and the tariff cut. So for government, I think that what is important is to find the right balance between the incentive mechanism and making sure not to push this to a level which will not be sustainable in the future. So let's go through the regulatory framework. We won't have the time to go in very much detail, but it is important because without those regulatory framework and incentive, the solar sector would never pick up.